Let's solve a physics problem involving two particles moving in a uniform gravitational field. In this problem, we have two particles that start from the same point at time equals 0. They move horizontally in opposite directions, with particle 1 moving to the right at 3.0 meters per second and particle 2 moving to the left at 4.0 meters per second. Both particles are in a uniform gravitational field, so they accelerate downward with the acceleration of gravity g. As time progresses, the particles follow parabolic trajectories due to gravity. Their horizontal velocities remain constant, while their vertical velocities increase continuously in the downward direction. Let's illustrate how the velocity vectors for both particles evolve over time. At time t, the velocity vector of particle 1 is 3.0 meters per second horizontally and negative g times t vertically, where g is the acceleration due to gravity. Similarly, for particle 2, the velocity is negative 4.0 meters per second horizontally and also negative g times t vertically. We're asked to find the distance between the particles when their velocity vectors become perpendicular. Let's see what this looks like visually. Two vectors are perpendicular when their dot product equals 0. Let's calculate the dot product of the velocity vectors at time t. The dot product equals 3.0 times negative 4.0 plus negative gt times negative gt, which simplifies to negative 12 plus g squared t squared. Setting this equal to 0 and solving for t. Negative 12 plus g squared t squared equals 0. G squared t squared equals 12. T squared equals 12 over g squared. And t equals the square root of 12 divided by g, which equals 2 times the square root of 3 divided by g. Now, let's find the distance between the particles at this time. At time t, the horizontal positions of the particles are x1 equals 3.0 times t, and x2 equals negative 4.0 times t. Since both particles are falling under the same gravitational acceleration, they fall the same vertical distance. So the separation is purely horizontal. The horizontal distance is x1 minus x2, which equals 3.0 times t minus negative 4.0 times t, which simplifies to 7 times t. Substituting our value for t, the distance equals 7 times 2 root 3 over g, which equals 14 root 3 over g. Numerically, with g equals 9.8 meters per second squared, the distance is approximately 2.47 meters. Let's visualize the final situation, where the particles have moved apart and their velocity vectors are perpendicular. The horizontal distance between them is 14 root 3 over g, which is approximately 2.47 meters, when g equals 9.8 meters per second squared. So our final answer is the distance between the particles when their velocity vectors become perpendicular is 14 root 3 divided by g, which is approximately 2.47 meters.